sixth question, we need to find the true statement regarding emission spectrum. First statement, the gaps between the lines in a line spectrum decrease as the frequency increases. What do you think about that statement? Let's consider the hydrogen emission spectrum. This is the visible region of hydrogen emission spectrum. So frequency increases in this direction from red to violet. What happens to the gap between two lines? The gap decreases when frequency increases. Therefore, it seems that the first statement is correct. But when we consider spectrum of sodium, spectrum of calcium, spectrum of mercury, we cannot observe that pattern. When we consider any atomic spectrum other than atomic spectrum of hydrogen, that pattern cannot be observed. Therefore, in general terms, the first statement is incorrect. The gaps between the lines in a line spectrum decrease as the frequency increases. That statement is valid only for hydrogen spectrum or spectrum of hydrogen. So, in general terms, that statement is incorrect. Then what about the second statement? Emission of radiation occurs when electrons transfer from lower energy levels to higher energy levels. So what happens when electrons transfer from lower energy levels to higher energy levels? When an electron transfer from lower energy level to higher energy level, the electron absorbs the required energy. If electron absorbs energy, it cannot release radiation. It absorbs radiation. Therefore, it's clear that the second statement is also incorrect. Then what about the third statement? The lines of the hydrogen spectrum diverge rapidly as the frequency increases. It's clear that when frequency increases, lines converge. Therefore, third statement is also incorrect. The emission spectra of hydrogen atom and helium plus ion are identical. That is incorrect. Because these two are two species, the emission spectra cannot be identical. But the number of lines in those two spectra can be equal. What is the reason? When we consider hydrogen atom, there is only one electron. When we consider helium ion, there is only one electron. Therefore, electron transfers can be same. Therefore, number of lines in the spectrum can be same, but they are not identical because energies are different in those two atoms. So, now we can deduce that the fifth one is the correct. Therefore, the answer for this question is fifth one. When we consider the visible region of hydrogen spectrum, the lines are named as H alpha, H beta, H gamma, H delta, H epsilon, like that. Usually we consider only first four lines. So we can consider about the energy transitions. You should know that energy transition for the visible region of hydrogen spectrum ends or begins at the second principal energy level. fourth principal energy level, fifth principal energy level, sixth principal energy level. So when we consider H delta, that is the highest energy transition. So this energy transition is related to H delta. Then what about H gamma? The energy transition is little bit less than that, the previous one. Then what about H beta? Then we can mark H alpha. What about the fifth statement? The electron transition from n equals 3 to n equals 2 corresponds to the H alpha line. Yes, that is correct. When electron releases energy, when it transfers from third principal energy level to second principal energy level, it generates H alpha spectral line. Therefore, it's clear that the fifth statement is correct. That's how you should get the correct answer to this question. If you want to boost your chemistry marks, you can join our online paper discussion class. WhatsApp now to join. Don't wait. To get this question paper free of charge, WhatsApp now to 071 7191 626.